Okay, this question is a temperature time graph. Okay, so one is being wrapped with cotton wool, the other is without. Okay, water both at 80 degrees Celsius. So it loses heat to the surrounding. So you can see both sides at 80, right? So you can annotate this way, both sides 80. And then can Q cool down faster? But here there's an important word here. They say state the difference in temperature of the water in the two cans at the fourth minute. So you take this reading here and take this reading and then minus. So it's 50 minus 40. So answer is 10. Okay, 10 degrees Celsius. Okay, so you put 10 degrees Celsius, the degree, right? Let's see. 10 degrees Celsius. Quite easy, right? 50 minus 40. Next, explain why there's a difference in temperature of the water in two cans. So the part A answer is, okay, let me bring down here because this one not enough space to write. Okay, put part B. Okay, you see can R, right, has cotton wool, which is shown here, can R. So it acts as what? Okay, because it traps air, so air is a poor conductor of heat. Hence, the hot water in can R loses heat slower to the surrounding than the water in can Q. Okay, in can Q. So can Q, okay, so this answer, can R has cotton wool that traps air. Air is a poor conductor of heat. Hence, the hot water in can R loses heat slower to the surrounding than the water in can Q. Okay, there's another way of saying second possible answer, you can say, or air in the cotton wool conduct heat slower from can R to the surrounding. So two possible answer for part B. Okay, I will screen share this and then let you write down the answer. Okay. Okay, give a reason why Sammy needs to set up can Q as a control setup. Okay, control setup is to compare and confirm. Whenever we talk about control setup, right, the answer is quite straightforward. I put it here. This is part C. To compare and confirm that the change in temperature of the water, which is the measured variable, in the cans is due to the presence of cotton wool, or you can say due to the presence of air in the cotton wool wrapped around the can. Okay, the MV stands for measured variable. The CV is called a control variable, right? Yeah. But this one is not necessary. I just remove this one. Okay. MV. MV is a measured variable. The CV is a control variable. Okay. To compare and confirm this one. Okay. Control setup. So this is a standard way to answer control setup. To compare and confirm the change in temperature of water in the cans is due to the presence of cotton wool or the presence of air wrapped around can R. So this question is a good question. Okay, this question is quite simple, but also quite easily forgotten by students. State the difference between boiling and evaporation. So there are many possible answers, which I just show you two. So you can mention this. Boiling takes place at a fixed temperature, but evaporation takes place at any temperature in the liquid state. Or you can say boiling takes place throughout the liquid, but evaporation takes place on the surface of the liquid. Okay. So these are the two commonly asked questions. Okay, next. Okay, this one is a condensation happening when you open the ice box, right? So there's this mist. Identify the change in state that caused the mist to be formed. Because mist is caused by the condensation of water vapor. So it's from gaseous to liquid state. So this one you just mentioned. Part A, right? From gaseous to liquid state. Part B, explain how the white solid was formed on a packet of frozen food. Okay, this one is a two-step thing. So step one, the warmer water vapor from the surrounding loses heat. So they condense to form tiny water droplets. Second step, the tiny water droplets lose heat further to form the ice. Okay, so this is how we write for this part. Warmer water vapor from the surrounding touches the cooler surface of the frozen food, lost heat and condensed to form water droplet. Then the second step, the water droplets lost heat to the frozen food to form ice. Okay, two-step. Say two-step, I write here. These are the two-step. So I do a screen share and capture this for the student. Okay, so two-step, this one take note. Okay, this one you need to understand how it works, right? So when you close the switch here, right, the current from here will flow through this part. Okay. So because metal can conduct electricity, correct? And it will flow through here. Because this is made of steel, so it will go through here. Okay, then you happen, you see this part, right? It will be magnetized. So they will attract the movable steel bar there. Okay, once they move there, right, is disconnected. Okay, when it's connected, this one will light up. So disconnect, so it will cause this bulb to flash. Okay, it will cause this bulb to turn on and off. So this is how we explain. Quite long, this one. Like I tried to put it here. Okay, when the switch too big, make it smaller. When the switch is closed, the electric current flow to the closed circuit. Let me see. Maybe I put it below, easier to see, without a line distraction. So this is part A. Yeah. When the switch is closed, the electric current flows through the closed circuit to light up the bulb. So the iron is magnetized. It becomes an electromagnet and attracts the steel bar, causing an open circuit. So the bulb does not light up. Okay, I try to minimize this extra thing. The circuit magnetize and attract. Okay. Causing an open circuit, so the bulb does not light up. Okay. Okay, then this caused the current to stop flowing to the circuit. The iron rod is no longer an electromagnet. I say it's demagnetized. Oh, the steel bar falls back to bar wire, forming a closed circuit, and the bulb lights up. So this one is quite tedious. I split up this one to let you see easier. Okay, so it turn on and off. Okay, I remain here, then I screenshot, easier to see. So this is part A. Okay, part B. Suggest one change to the electric circuit to increase the rate of flashing. Okay, this one is a bit tricky. There are three possible ways. You can increase the number of coil, increase the number of battery, or reduce the distance between the iron and steel bar. But the last one is actually the easiest, but somehow most students can't think of this method. So part B, right? Three possible answers. Okay. You can increase the number of coil or wire around the iron rod, or increase the number of batteries in a circuit, or reduce the distance between the iron rod and the steel bar. So there are three possible answers for this question. Okay, pause recording. Okay, here at her booth, Sharifa had a mystery light box as shown. So she played with the switches S1 and S2, these two switches, and record her observation as below. So you're supposed to connect this part, okay, so that when S1 is closed, B1 light up only. When S2 closed, all the bulb did not light up when S2 closed. When you close both, right, all three bulbs light up. However, B2 and B3 are dimmer. So B2 and B3 dimmer means they give a hint, they are connected in series. Okay. So screenshot answer key for you to see. So this answer. Can you see when S1 is closed, right? When S1, okay, this part, when S1 closed. Okay, let me draw. Okay, when S1 closed, right? So the B1 only light up. You can see when S1 closed. Correct, right? When S2 closed, all three will light up, correct? All three will light up. When you close both, right? B2 and B3 will be dimmer because B2 and B3, they are connected in series. So this question quite tricky. Take some time to think through. This one, 37C. Yeah. Yeah, 37C. So this because they say when S1 close, B1 light up. When S2 close, all bulbs do not light up. When S2 close, let me see, when S2 close, because you know why when S2 close, all cannot light up? Because S1 is a master switch. S1 is open, so the current can't even flow through. So when S2 is closed, all three bulbs cannot light up. Okay, then when both close, right? B1 and B2 and B3 are dimmer. Okay, because you see here, right? When you close both, right? B1 actually is independent. Okay, that means this two battery is lighting up B1. But because B2 and B3, they are connected in series. They are sharing the current from this battery over here. So this is the answer for this question. Okay, Ken? Okay, let me continue the next question. Coming back to here. Done. Okay, next question is about this Bungie jar. Okay, you think note, you have me put here as Z because this is missing here. So this position Z. Okay, this one is actually a reverse Bungie. You can take this right in Singapore at Clarke Quay. Okay, in Clarke Quay. So the gravitational force remain the same because gravitational force is gravity, and then the elastic spring force decreases. So the answer for these two. Okay, they say when the capsule move from point X to point Y, so elastic spring force, because it has released, it decreases. Explain in terms of forces why the capsule move more slowly when it move from point Y to point Z and from point X to point Y. Okay, why it moves so slow. So you talk about, okay, this one answer quite long. Let me copy the answer and send to you this part. Let me put it below here easier. Very long answer, I see. Okay, let me shorten this part. Okay, from point Y to Z, right? The elastic band is more stretched. So there's more elastic spring force acting on the capsule. Y to Z. Then from move more slowly, Y to Z. From point Y to elastic band is it more stretched? Let me see. is more stress, so it's more elastic spring force. Okay. So from point X to Y, capsule is going opposite direction. However, from Y to Z, is going in the opposite direction of both gravity and elastic spring force. Gravity go down, elastic spring force also coming down. Okay, wait, this part. Huh? 615 already. Okay, I screenshot this answer for you first. Then you all go and digest this part. Okay. Okay, this part, you all take note. It's quite long, the answer. You try to digest this part. They ask you to explain why the capsule moves more slowly from Y to Z. Because Y to Z, like, is the spring is pulling it down and it's going against gravity. Then from X to Y is being stretched, so they like throw the thing go out. They throw the capsule go out. X to Y. Okay, so this part you all take note. I will pause the recording.